Welcome to today's class. We'll be talking about trigonometry. This class will actually lay emphasis on just trying to introduce what trigonometry is actually all about. Okay? Trigonometry, first and foremost, is the geometrical study of triangles. Trigonometry comes from two words, trigonometry. Trigon from the word triangle, and metry, which means measurement. So trigonometry is essentially the study of the measurement of triangles. And basically, what is a triangle? Triangle is simply a plane shape that is bounded by three straight lines. So people prefer to define it as a polygon with three sides. But one thing is certain, polygons have three or more sides, and the smallest category of polygons are called triangles. It follows, mathematicians tend to believe that if we actually understand the smallest polygon, then we can actually understand the largest polygon, because everything is simply an extension of a triangle. You put two triangles together, it makes a quadrilateral. You put three triangles together, it makes a pentagon. You put four triangles together, it makes a hexagon, like that continually. There's a way you can actually arrange triangles and to form multiple forms. And so a proper understanding of a triangle is simply a proper understanding of the polygon. So this becomes the basics for which the Euclidean geometry of polygons is properly understood. Now, triangles are categorized into four. Some people prefer to categorize into three and don't really consider the last as a separate category, but it's because sometimes it can overlap and fall in between. But they are actually categorized into four. Triangles that have all their sides equal are called equilateral triangles. Triangles that have two of their sides equal are called isosceles triangles. Triangles that have all sides being unequal are called scaling triangles. And triangles that have at least one of the angles within them being 90 degrees is called a right angle triangle. It's called a right angle triangle. It's possible that an isosceles or a scaling triangle, for instance, can be a right angle triangle by conventional design. Okay, it's very, very possible. So it overlaps between these two. Of course, it can never fall into the equilateral triangle because all the angles are equal and always 60. But it tends to fall in between these two. We also have an isosceles right angle triangle, and we also have a scaling right angle triangle. But among all of this triangle, the one that has more interest and the one that sparks more light is the right angle triangle, because it is believed that every of this type of triangle can be broken down into two right angle triangles, as we show here. For instance, this is an equilateral triangle. If you try to bisect from the top down, you end up having two right angle triangles, and two triangles with angle 90 degrees within them. Okay? Looking at an isosceles triangle where the two sides are equal, if you do the same bisection procedure, you have this. And then looking at a scaling triangle, not necessarily a bisection, but just a perpendicular line drawn to cut through or to pass through to intersect. A perpendicular intersection, basically, it doesn't really necessarily cut this angle into two equal halves, neither does it necessarily cut this line into two equal halves. But one thing is certain, once it is drawn, if you draw a perpendicular from this point, this angle up to this point, you have 90 here, you have 90 here, and two right angle triangles. So if we can understand the right angle triangle, we can understand all these other triangles put together. So now our focus on this study in trigonometry will always be the right angle triangle. Let's try to understand it. What's it all about? Now, taking the right angle triangle into consideration, we have this particular case. Let this point be A, this point be B, and this point be C. Okay? This point be A, this point be B, and this point be C. The next thing we're going to see there is the side directly opposite facing A is a small letter A. Is labeled a small letter A conventionally. The side directly facing B, C, is labeled a small letter C. The side directly facing is labeled small letter C. The longest side, which is the side facing the right angle triangle, is always called the hypotenuse. The first thing that we have to know about the right angle triangle is simply Pythagoras theorem. That's the first thing that must be noted about the right angle triangle. And what is that all about, or what's that trying to insinuate? That's trying to say that the sum of the squares of the two shorter sides is always equal to the square of the longest side, which is the hypotenuse. That's the side that is directly facing the right angle. Okay, so this particular side is often called hypotenuse. Okay, please don't be stereotypical. This side is not always opposite, and this side is not always adjacent. It depends on the angle you're considering. If I'm considering A, then this side is opposite and this side is adjacent. If I'm considering B, then this side is opposite, this side is adjacent. It depends on the direction you're considering. But Pythagoras theorem essentially states that C square must be equal to A square plus B square. A very, very fundamental thing. Hypotenuse square is simply the sum of the squares of the two shorter sides. Square of the hypotenuse is the sum of the squares of the two shorter sides. So that's a brief introduction into the very first fundamental aspect of trigonometry. Let me clean the side of the board and then we will run a little bit of example on this case before we go into trigonometric ratios. Now, Pythagoras theorem on its own is a very simple thing to do. Anyone should be able to find a third side, a triangle given a particular side. So the problem we're going to do is going to be a little bit off the charts. We're going to do it a step up beyond the normal way it has been done in class per se. Okay, proceed with me. Look at the example we're considering. Look at this example. We're to find x. If one of the shorter side is x plus 1, the second shorter side is x plus 2, and the longest side is x plus 3. How do we go about this? It's pretty much simple. We simply know from Pythagoras theorem that the longest side, the square of the longest side, is equal to the sum of the squares of the two shorter sides. Sum of the squares of the two shorter sides, essentially. Okay, so if we proceed by that, this is going to be x plus 3 squared is actually going to be equal to what? X plus 1 squared plus x plus 2 squared. Let's expand this. Take this first one, multiply everything in this bracket. So x times x is x squared. X times 3 is 3x. Now take this 3, multiply everything in the bracket. 3 times x is 3x. 3 times 3 is 9. And this is going to be, in the same way, this is going to be x squared plus x plus x plus 1. And then this is going to be x squared. To extend this bracket plus 2x plus 2x plus 4. So let's simplify. This becomes x squared plus 6x plus 9 is equal to x squared plus x squared is 2x squared, x plus x 2x plus 2x 4x plus 2x plus 6x plus 1 plus 4. That's 5. Alright, you have x squared. Let's get all the x to one side. Minus 2x squared plus 6x minus 6 equals to 5 minus 9. X squared minus 2x squared is minus x squared. 6x minus 6x, that's 0. 5 minus 9, that happens to be minus 4. If we divide both sides by minus 1, that goes, so you're left with x squared is equal to 4. Take square root of both sides. Essentially, there should be a plus or minus. Now, this just would imply that x is equals to a plus or minus 2. Since we're dealing with real world examples and real world problems, we know distances cannot be negative. I think the answer we're actually looking for is the positive 2. And so that has been found. Thank you. This is how we use Pythagoras theorem. Questions could be framed in any form, but this question was actually framed to match the level of the students actually doing the course. Thank you for watching. Don't forget to like us and contact us on the number that is being displayed on the screen.